All right, so our objective today is to find ways to prove quadrilaterals are parallelograms. And we are looking at lesson 5-2 from our textbook. So again, I've got 4 theorems and a small proof, and then we have a wrap-up of all of that. All right, so number 1 theorem. And unfortunately, I don't think we have a single theorem in this chapter or postulate that has a name. So theorem 5.4 says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay. And just to kind of, how would we go about making sure that's true? So we've got a quadrilateral, QRST. We, at that point, really couldn't do much. We know that this is congruent to this side is congruent to this side, so what we would do is use reflexively draw in that auxiliary line and use it as reflexive for both triangles, prove the 2 triangles are congruent. From there, we would pull out angle 3 and angle 4, angle 1 and angle 2 being congruent to each other through CPCTC. Now, if you notice, angles 1 and 2 are formed by that set of parallel lines. So we would get those 2 sides parallel with angles 1 and angle 2. We would get 3 and 4 would be proved, we could prove, knowing that they're congruent, that TS and QR would be parallel to each other. And that's the only thing we have to work with right now, is to prove that we have a parallelogram, is that we have both sets of opposite sides being parallel. And so that's how we would go about proving that, okay? All right, let's see, do I have room? Yeah. So the other theorem, next theorem, is theorem 5.5. Funny, I had to look at that. And that one states, if one pair of opposite sides of a quadrilateral are both congruent, and parallel, then the quadrilateral is a parallelogram. So we're going to do a proof of theorem 5.5. So let me go to the next screen. And what we would be given would be that we have one set of sides segment AB and segment CD being congruent to each other, as well as the same set of sides being parallel to each other. So when this condition is met, the conclusion that we get to draw is that we have a parallelogram. So ABCD is a parallelogram. So let's draw our parallelogram. A, B, C, D. And the given information is that segment AB and segment CD are parallel to each other and they're congruent. So now we need to somehow, now we've got Theorem 5.4 we can use, but that's not going to help us. So let's see, what else could we do? Okay, well, if we have parallel lines, we could do something with alternate interior angles, corresponding angles, same side interior angles. So I think what we're going to have to do is add an auxiliary line, and this would actually be drawn in for you at this juncture. And when we draw them in, the only way that we can put our angle numbers is here and here, because those three lines, again, just to reiterate, here's your parallel lines cut by a transversal. Angles 1 and angle 2 are formed by those parallel lines and transversal. Okay, so then we would be able to prove really quickly that angle 1 is congruent to angle 2, because if you have parallel lines cut by transversal, alternate interior angles are congruent. We again are going to have a auxiliary line can act as the reflexive property. So we can get those two triangles congruent. So now what I could do is prove that segment AD and segment CB are congruent through CPCTC, and now I'm going back to the Theorem 5.4. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? So that's what, we okay? Okay. Oops, sorry. That's not good. I think ears just glazed over. Now remember, anytime that I use an auxiliary line, I have to give reference to it. I'm not doing anything in terms of trying to bisect or be perpendicular, anything like that. So postulate 6 is going to be the one that we, or postulate, oh, yeah, it's postulate 6 or 9. Now I can think it's 6, right? Do we need 2 points? There's exactly one line. Sorry. So let's draw that auxiliary line. So remember, anytime you hear the words draw, that means that you don't have to use a ruler. You don't have to construct it, in other words. Andy, looks like you're leaving. So through any 2 points, there is exactly one line. And then we would get angle 1 being congruent to angle 2 if two parallel lines cut by a transversal, then alternate interior angles are congruent. We need to bring in our reflexive. Segment BD is congruent to itself. And then we would be able to get, bless you, triangle ABD would be congruent to triangle CDB. And the reason would be side, angle, side postulate. We bring out our CPCTC, that segment AD would be congruent to segment CB. And now we have both sets of opposite sides of that quadrilateral are congruent. So we can say ABCD is a parallelogram. Let's see, can I cram it all in there? Hold on. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So you can see how I abbreviate that guy. So that's your theorem 5-4. So remember, once we hit 5-5, we can use 5-4 and in the back. Okay, Rachel E.
Isn't that a square for the parallelogram?
As long as, well, again, are both sets of opposite sides parallel? Yes. Because the same side interior angles are supplementary, if you think about it, because you have all 90s. So, yeah. But we can't just assume that. We have to prove it. Okay. All right, so I've got 2 more theorems for you. Everybody good? So, next theorem. Let's go to orange. Theorem 5-6. See, it says, it says if both pairs, you knew this was coming, of opposite what? You already did sides. Oh, yeah. If both pairs of opposite angles are congruent. Oh, both pairs of opposite angles, hold on, I forgot some piece, of a quadrilateral. Always forget that piece. Are congruent. Then the quadrilateral is a parallelogram. Okay. And then the last one, theorem 5-7. Says if, oh, you knew this was coming, if the diagonals, remember our last one, 5-3, said the diagonals of a parallelogram bisect each other. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So to recap, we now have 5 ways to prove a quadrilateral is a parallelogram. This is not a vocab card. Way 1.
Is it supposed to say sways?
5. 5 ways. Yeah, I'm swagging today, okay? I'm swaying and swagging, okay? 5 ways. All right, you're scaring me now. All right. Show, number 1, both pairs of opposite sides are parallel. So that's your theorem 5-3. Next, or actually, that's not true. Oops, sorry. That is actually the definition of a parallelogram. Let me write that underneath here. Okay. Second way. Okay, wait a second. Yeah, that's right. Sorry, brain. Show both pairs of opposite sides are congruent. That is Theorem 5.3. Show one pair of opposite sides. Oops, that's an interesting formation of words. Opposite are both parallel and congruent. That's your Theorem 5.4. Fourth way. Show both pairs of opposite angles. Are congruent. That's your Theorem 5.5. Oh, I've got my numbers wrong, don't I? This is 5.4, 5.5, 5.6, 5.7. Heavy sigh. No, that's panting. That's different there, Aiden. Okay. And last but not least, we're going to deal with the diagonals. Show both diagonals bisect each other. And that's your Theorem 5.7. Okay?